So hello everyone, today we'll see questions related to differentiation of vectors. There were only 5 questions asked on this topic, 3 in civil services examination and 2 in forest service examination, and these questions are pretty easy, so let's see them one by one. So the question 1 is, the position vector of a moving point at time t is given by this. So the position vector at any time t is given to us by sin t I cap plus cos 2t j cap plus t square plus 2t k cap, and we are supposed to find the components of acceleration in the direction parallel to velocity vector v and in direction perpendicular, and basically we are supposed to find acceleration also in direction perpendicular to plane of r vector and v vector at time t equals to 0. So first of all we need to since the position vector is given to us, we need to evaluate basically velocity vector and acceleration vector at any arbitrary time t. So the velocity vector will be equals to differentiation of position vector with respect to t, which will be equals to cos t I cap plus minus 2 sin 2t j cap plus 2t plus 2k cap. Likewise, we can find acceleration vector, which will be basically a derivative of velocity vector with respect to time t, or double derivative of acceleration vector with respect to time t, and it will be equals to minus of sin t I cap plus minus of 4 cos 2t j cap plus 2k cap. Now since we are supposed to evaluate both the acceleration at time t equals to 0, so what we'll do is we'll evaluate basically velocity, all these three, position vector, velocity vector and acceleration vector at time t equals to 0. So at t equals to 0, position vector will be 0 I cap plus j cap plus 0 k cap. Likewise, velocity vector at time t equals to 0 will be I cap plus 0 j cap plus 2 k cap, and acceleration vector will be equals to 0 I cap minus 4 j cap plus 2 k cap. So this is the velocity, position and acceleration vector at time t equals to 0. So first we are supposed to evaluate acceleration in direction parallel to velocity vector. So component of acceleration in direction parallel to velocity vector will be basically given by a vector dot v vector divided by absolute value of v vector times v cap. So it will be equals to, our acceleration vector is minus 4 j cap plus 2 k cap, and our velocity vector is I cap plus 0 j cap plus 2 k cap divided by absolute value of velocity vector, that will be 1 square plus 0 square plus 2 square times the unit velocity vector, and it will be I cap plus 2 k cap divided by square root of 1 square plus 2 square. So it simplifies to 4 times I cap plus 2 k cap divided by, from here we'll get square root of 5 and from here also we'll get square root of 5, so it will be 5 only. So component of acceleration in direction parallel to velocity vector will be equals to 4 by 5 times I cap plus 2 k cap. Now another thing that we were supposed to evaluate is component of acceleration in direction perpendicular to plane of r vector and v vector at time t equals to 0. So first we need to evaluate the direction which is perpendicular to both r vector and w vector. So let w vector be a vector in direction perpendicular to both r vector and v vector at time t equals to 0. So w vector will be given by cross product of r vector and v vector. So it will be equals to I, j, k, and my r vector is 0, 1, 0 and v vector is 1, 0, 2. So it will be equals to I cap 2 minus 0 minus j cap 0 plus k cap 0 minus 1. So it will be equals to 2 I cap plus 0 j cap minus k cap. Now we are supposed to evaluate a component of acceleration in direction of w vector. So it will be equals to a cap dot w cap divided by absolute value of w cap times unit vector w cap. So it will be equals to, my acceleration is 0 minus 4 2, 0 I cap minus 4 j cap plus 2 k cap times 2 I cap plus 0 j cap minus k cap divided by absolute value of w. So it will be 2 square plus 0 square plus minus 1 square times w cap. So it will be 0 times 0 0 minus 2 times minus 2 divided by square root of 5 times 2 I cap plus 0 j cap minus k cap divided by square root of 2 square plus 0 square plus minus 1 square. So it will be equals to minus 2 by 5 2 I cap minus k cap. So this is the component of acceleration in direction parallel to w vector, which is basically perpendicular to both r vector and v vector at time t equals to 0. So let's move on to discuss the next question. So the next question is, they have given us a vector and b vector and we are supposed to evaluate this quantity at this point, and it's asked in 2012 civil services examination. Now in order to evaluate it, first we need to evaluate a vector cross b vector. Basically we need to do cross product of a vector and b vector. So a vector is given to me as x square yz I cap minus 2x z cube j cap plus x z square k cap. Likewise b vector is given to me as 2z I cap plus y j cap minus x square k cap. Now if I evaluate a vector cross b vector, it will be equals to I j and k. Here we have x square yz minus 2xz cube xz square, and here we have 2z y minus x square. So it simplifies to I cap times 2x cube z cube minus xy z square minus j cap times minus x raised 4 yz minus 2xz cube plus k cap times x square y square z plus 4x z raised 4. So this is the a vector this is a vector cross b vector. Now I need to first evaluate its partial derivative with respect to y, and then we have to evaluate that with respect to x. So its partial derivative with respect to y will be given by I cap minus xz square minus j cap, or let's make it plus j cap, x raised 4z plus k cap 2x square yz Likewise, if I evaluate this with respect to x, so it will be equals to I cap minus z square plus j cap times 4x cube z plus k cap times 2 to the 4xyz. And this is basically the vector, and we are supposed to evaluate it at 1 0 minus 2 point. So del square a cap cross b cap at 1 0 minus 2 will be equals to minus 4 I cap minus 4 j cap. It will be minus of 8 j cap plus 0 k cap. So it is equals to minus 4 I cap minus 8 j cap. And that's all we are supposed to evaluate in this question. Let's move on to discuss the next question. So the next question is, for two vectors a vector and b vector given by this, we're supposed to evaluate these two quantities, and it's as in 2011 civil services examination. So a vector is equals to 5t square I cap plus t j cap minus t cube k cap. Likewise, b vector is given by sin t I cap minus cos t j cap. So if I evaluate a dot b, so it will be equals to 5t square I cap plus t j cap minus t cube k cap dot sin t I cap minus cos t j cap. So it will simplify to 5t square sin t minus t cos t. And if I differentiate it with respect to t, so I'll get 10t sin t plus 5t square cos t minus cos t plus t sin t. So it will be equals to 11t sin t plus 5t square cos t minus cos t. Likewise, second part of the question is, we are supposed to differentiate cross product of a and b with respect to t. So for that, first we need to evaluate cross product of a and b. So that will be equals to 5t square t minus t cube sin t minus cos t and 0. So it simplifies to I cap minus t cube cos t minus of j cap t cube sin t plus k cap minus 5t square cos t minus t sin t. So if I evaluate its derivative with respect to t, so it will be equals to I cap minus 3t square cos t plus t cube sin t minus j cap 3t square sin t plus t cube cos t plus k cap minus 10t cos t plus 5t square sin t minus sin t and minus t of cos t. So this is the derivative of a cross b with respect to t. So that's all asked in this question, so it completes this question as well. Let's move on to discuss the next question. So the next question says that position vector r vector of a particle of mass 2 units, mass is 2 units, so its position vector at any arbitrary time t is given as this, and it is, so position vector at any time t is t square minus 2t I cap plus 1 by 2 t square plus 1 j cap plus 1 by 2 t square k cap. So we're supposed to evaluate at time t equals to 1 its kinetic energy. So first let's evaluate that only. So kinetic energy will be equals to half mv square, and it can be written as half m v vector dot b vector. So it will be 1 by 2, since mass is 2 units, so it will reduce to dot product of v vector with v vector. Now since position vector is given to us, so we can easily evaluate the velocity vector. So velocity vector will be equals to derivative of position vector with respect to t. So it will be 2t minus 2 I cap plus t j cap plus t k cap. Now its dot product with respect to velocity vector will be 2t minus 2 square plus t square plus t square, and at t equals to 1 it will be equals to 2 minus 2 0 plus 1 which is 2. So kinetic energy, which I am denoting with Ke, will be equals to 2 units. Next thing that we are supposed to evaluate is angular momentum. So the formula for angular momentum is given by L, and it is R times mv vector. So it will be equals to R at t equals to 1 will be, here I am writing it, R at 1 will be equals to minus I cap plus 3 by 2 j cap plus 1 by 2 k cap, and velocity vector at t equals to 1 will be equals to 0 I cap plus j cap plus k cap. Now if we evaluate it, it will be 2 times, that comes from mass. Since mass is constant, so we can pull it out. So it will be I cap j cap k cap minus 1 3 by 2 1 by 2 0 1 1. So it will be 2 times of I cap 3 by 2 minus 1 by 2 minus j cap minus of 1 plus k cap, which is again minus 1. So it will be 2 times of I cap plus j cap minus k cap. Another thing that we are supposed to evaluate is, this is the angular momentum. Let's write it as AM or L cap. Another thing that we are supposed to evaluate is time rate of change of angular momentum. So time rate of change of angular momentum will be given by L, like basically derivative of L cap with respect to t. So it will be t by dt r cap cross mv cap, which will be given by dr cap by dt cross mv cap plus r cap cross m dv cap by dt. So dr cap by dt is v vector only, so it is v vector cross mv vector plus r vector cross m d vector by dt. Since cross product of a vector with itself is 0, so this term reduces to 0 only, so we'll be left with the second term only. So let's evaluate it. So first let's evaluate dv by dt vector. It will be equals to from here 2 I cap plus j cap plus k cap. It is 2 I cap plus j cap plus k cap. So dl vector by dt will be equals to r vector at t equals to 1, which is 0 1 1, 0 I cap plus j cap plus k cap, cross product mass, that is 2 units, time dv by dt, that is 2 I cap plus j cap plus k cap. Now if I evaluate it, I can pull out this 2 here, and its cross product will be equals to 2 times of I cap j cap k cap, and it will be 0 1 1 2 1 1. So it simplifies to 2 times of I cap 1 minus 1, that is 0, minus j cap 0 minus 2 plus k cap 0 minus 2, and it simplifies to 2 times of 2 j cap minus 2 k cap, which is 4 of j cap minus k cap. I guess I have mistakenly used velocity, like value of v. So the r vector at t equals to 1 is minus I cap plus 3 by 2 j cap minus I cap plus 3 by 2 j cap plus 1 by 2 k cap. So if I evaluate it, it will be equals to minus 1, 3 by 2, 1 by 2, and it simplifies to 2 times of I cap 3 by 2 minus 1 by 2 minus j cap, which is minus 1 minus of 1 plus k cap minus 1 minus 3. 3 by 2 minus 1 by 2 is 1 plus 2 j cap minus 4 k cap, and it simplifies to 2 I cap plus 4 j cap minus 8 k cap. That's the angular rate of change of angular momentum. And last thing that we are supposed to find, momentum of resultant force acting at a particle about origin. So momentum of resultant force is basically torque. So momentum of resultant force, which is given by torque, is r vector cross f vector, and force is where f is force, and force we can easily evaluate by mass into acceleration. So here it will be 2 times of r vector times acceleration, that is r vector is minus 1 by 2, 3 by 2, 1 by 2, and acceleration will be 2 1 1. So it again simplifies to 2 I cap plus 4 j cap minus 8 k cap units. So this completes this question as well. And last question for this topic is, prove that the necessary and sufficient condition for vector function v vector of scalar variable t to have constant magnitude is this. So let us assume that v vector is a vector in scalar variable t. Here t is a scalar variable, and we are supposed, if it is basically of constant magnitude, that means this is equals to c, then we are supposed to show that this relation holds, and vice versa. So let us assume that it's of constant magnitude. So this can be written as dot product of vt with itself must be constant. Now if I differentiate it with respect to t, so what I'll get is dv cap by dt dot vt plus v dash t dot dv dash t by dt equals to 0. Now we know that in dot product a dot b is same as b dot a. So from here we'll get that 2 times of vt dot dvt by dt is equals to 0. So from here vt dot dvt by dt is equals to 0, and that's what we are supposed to prove. Now if this condition holds, we need to show the opposite result as well. So from here the converse part, if vt dot dvt by dt is equals to 0, so from here twice of this term will also be 0, and it can be written as 2 times, it can be written as this, vt dot dvt by dt plus dvt by dt dot vt equals to 0, and it can be written as derivative of vt dot vt with respect to t, and if the derivative is 0, so from here we can conclude that vt of dot vt must be equals to some constant, and this term is basically magnitude of v. So from here we got that if the given relation holds, then magnitude of v vector is 0. So this proves the necessary and sufficient condition both. So this completes our question on differentiation of vector, and only these many questions are also asked on this topic. In tomorrow's video we'll see some new topic. Thank you for watching, and please do like, share and subscribe the channel.